Hey guys, welcome back to my channel, and in this video I want to share with you how to create a radar shader effect that you may want to use in your game or in your game engines. Believe it or not, it's very simple how to create something like this, and you can integrate it in your game quite nicely and easily. So let's get started, all right? And just so you know, we are going to use some functions, all right? We're going to use a function that will take the space, assign distance function for a line, and then the modulus function, all right? Now, before I go on, I want you to understand this. I am using the metal shading language right now, and you probably want to use the OpenGL shading language. All right. Don't focus on the language. Focus on the concept. Understand the idea. Understand the concept of how you can manipulate shaders and create really cool effects. If you understand the concepts, then the language that you end up using doesn't really matter because you will be able to port it from one language to the other. So focus on the concept, and that is what I want to share with you today. All right, so one of the first things that we want to create are the rings around the shape, right? And you may think, well, what I have to do is create some rings and then do a for loop and then, do three of those rings in the for loop. That is okay, you can do that, but that's not the smart way to do it. There's a better, easier way to do that. And let me show you, okay? So the first thing that I'm gonna do, I'm gonna make a circle. All right, and what I'm gonna do here is, let me call it ring, okay? Rings, and I'm gonna get the length of the space st of the point, and I want to scale that up by 3. All right, and then if I were to obviously render this, what I would get would be something like this: float 3 rings. Right, I would get something like that. So how is this related to rings, right? Well, let me show you something that's going to surprise you. Okay, let's say if we get rings and we do something like just get the fractional points and not the integer, right? So if I do fract of rings, what do I get? Well, I will get something like that. This function, what it's basically doing is rendering the fractional part of the circle and ignoring the integers, right? So from 0.1 to 0.9, it is being rendered, but at 0.1, at distance 1, for example, it's not being rendered, it's being rendered black. And again, from 1.1 to 1.9, it is being rendered, but at 0.2, it is not being rendered. That is, it shows as black, and this is why you see the rings here, right? So how would that help us? Well, the cool thing is that we can sharpen these rings. And what I'm going to do now, I'm going to do a little trick, which I think would be better if I actually show you through graph. So let me go to this website called Graphtoy, which is very helpful when you are creating your own shaders. Right? And I recommend you to, to go and play around with this site because it helped me a lot, especially when I want to understand what's going on with the shaders. So first of all, let me get rid of all of this because we are not going to use this. All right. And now for the first function, let's say that we have a simple function which is called x. All right. So what do we get for that? Well, we get something like that. All right. Well, what happens if we do the fractional part of x, right? Well, if we do fract of x, what we get is something like this. And again, what's happening is that from 0.1, for example, to 0.9999, we get the actual value, right? We have that next a gradient going up. But then at integer 1, 0.1, we get 0. And that is exactly what you see here, right? Where you see that nice gradient going up and then goes to 0, up, and like that, right? So what happens if I do something like this, right? 1.0 minus, in this case, I'm going to call this f1x, because I'm putting that function, If I render this, what's going to happen is that I'm going to basically just flip the two, right? I'm going to go from one going that way to going that way, all right? So then what would happen if I only get that step, basically saying just render anything that is greater than zero point 0.1. What would happen, right? So if I do a step 0.1 comma f2x, you will get something like that. Basically, what this is saying is, A, if the function is greater than 0.1, then, you know, display a 1, right? Output it or a 1. If it's not, output a 0. And that is exactly what we have right here. So all of these guys are greater than 0.1, so that's why we're going to get a return value of 1. And whatever is less than 0.1, then we get a value of 0, and that is what we want, okay? Well, and where are we going with it? Well, just watch this. Because what I'm going to do next is I'm going to basically flip this now, all right? And what I'm going to do 1.0 minus f3, and if I do this, I get something like that. And why is that helpful? Well, because that is exactly what I want. I only want the rings to be displayed, to be rendered, and everything else to be 0. All right. So I'm going to basically copy this over into the shader, and to do that, or what I have to do, basically, let me do it this way. I'm gonna basically do this. I'm gonna do 1.0 minus a step, and then 0.1, and then 1.0 minus the frac of the rings. Okay, and if I do this, let me just double check. We get that. That is exactly what we want. If you look at the graph, that's what we were going for, right? So I'm just playing around with the function until I get the actual values that I want. All right, so now once we have this, we do know that we are going beyond our canvas in this example. And what we really want is we want to clamp the rings, the distance to go from 0 to, in this case, to 3. So what I'm going to do, I'm going to go rings clamp rings from 0 to 3, and I will clamp it to that. All right. Okay, so now this is cool, but now what? Well, before we move on, let me actually, okay, now let's just go for the next one. All right, so we have the rings. All right. What do we need to do next? Well, now we need to do the whole what goes around. I don't know the name of it, the spinning wheel, for example. So let's do like a spinning wheel. All right, and how we're going to do that, we're basically going to find the angle at a particular point, and we're going to use the tan inverse between the y and the x component of the vector, and then we are going to use the modulus function to make it rotate. All right, so for now, I'm going to do this. So let's get the angle. So float A equals the tangent inverse, A tan inverse, sorry, between SDY and SDX, right? Now, the problem with this function is that it returns a value between negative pi and pi. And there's nothing wrong with that. But what we want to do, we want to make it so that the value is between 0 and 1. And to do that, all what you really have to do is do A equals, you have to add pi to it, and pi here, and then divide that by 2 times pi. So 2.0 times pi. And what you get here is now that the return value is now from 0 to 1. And that is what we want, because we're going to use the modulus right now. So at this point, we do mod, and then we want this to, provide a time because we want it to always be going for time plus a, and we want it to be a modulus of 1. And what do we get when we have this? Well, let me show you. If I render this again, I'm going to get float 3 of a, and we get something like that, right? All right, so now that we have the spinning wheel, what we need to do is we want to combine the spinning wheel and our rings so that it creates a nice effect that we're looking for. But before we do that, we need to get basically the radius, right? We have the angle that we want the radius of the spinning wheel. And to get that, we're going to get float r equals length st, right? And I want to flip this around, right? And why do I want to do that? Well, let me just flip it right now, and I'm going to show you why. All right, let me show you this so you have a good idea. So if I do color float 3r, right, we get something like this. I mean, the circle at the center is white and the outer skirts are black. Whatever color I multiply this with, if I multiply color red times black, which equals, in this example, 0, then it's going to be 0. And the part in the center, which is 1, because it's white, is going to basically 1 times red, it's going to be red, right? So, and that is exactly what we want. If we would not invert this, we will get the opposite, right? Which means that the center will be multiplied by whatever color, but it's not going to affect it because anything multiplied times 0 is 0, right? So we want to do that. All right, so now that we have that, let me get the color here. Now I'm going to multiply my angle, the spinning, times r, all right? And we get something like that. At this point, it is the right moment for us to mix the rings and the spinning circle, right? And to do that, you can use mix or something like that, but I have found that if you use max, it actually does the interception, and you get something like this, which is quite nice, right? At this point, we want to say, well, you know what? I don't want this to be white. We want this to be color ring, so why don't we define that? Float 3 green. And we can multiply this. Boom, and we have something like that. All right, so the next thing that we need to do is basically render the lines, right? So, and for that, what we're going to do is we are going to use the sign the functions that I have here, and that if you want to know more about them, I'm going to provide a link to an article so you can read more about it and how you can actually derive them. I am not going to do that here, obviously. But basically, we're going to create 4 lines, right, perpendicular to each other. So to do that, we're going to say basically, we're going to do a for loop, int I equals 0, I less than 4, and I equals plus. And then what we want to do, we want to basically render 4 lines, right, perpendicular at each other, right? And one thing that you need to understand that when you are working with shaders, if you want to rotate an object, you do not rotate the object, you rotate the space where the object lives, all right? So since we're going to be making 4 rotations between 0, 90, 180 to 70, we want to rotate the space. So to do that, we're going to create a temperature. We're going to create a temp value. We're going to call it temp st. And we're going to copy the space onto that variable. So let me write this. Make a copy of the space. And so we're going to rotate this. We're going to rotate the space, and we're going to be using the function that I mentioned earlier, the rotate 2D function. We'll rotate the space. So now, it's going to be temp st st times rotate 2d, and in this case what we want to do, we want to rotate this times 90 degrees. And what I was going to do to make sure that this is in the right 180. All right. Okay, so we have rotated the space. So now let's make the line. Render the line. So let's see. Float L is going to equal the sine distance function. That's going to give me the shape of the line. I need to provide a space, temp st. That is basically what I need to provide as the arguments. This is the space, the point, and the starting segment point and the ending point. So I want this to start at 0 because I want it to start at the center, and I'm going to make it end at 1. All right, so I forgot to do this. Temp st. All right. Now what I want to do is I want to sharpen the lines, right? If you want to know why I'm doing this, you can watch my previous video where I show you how to do a simple loading circle. But basically, I'm going to use that function because if I were to render L right now, it's not gonna be sharp enough for us to appreciate it. So if I do sharpen, and then and in this case I'm going to make it very sharp 6, and then uniform resolution. All right, now since I'm going to have, I'm going to go for in the 4 times, I want to store the value on a variable that's going to help us to the final value basically. And I have already declared that value, that variable here, float m. So I'm going to just keep adding those values into m, and then we're going to use this. All right. So now I have m. Well, if I would render m, which is the addition of all the lines, right? So if I render m, what do I get? So float 3m, I will get that, right? Which is what we're looking for. So we have the splitting circle, we have the rings, now we have the cross-sectional lines, and it's time for us to combine them. And again, I'm going to use, one more time, I'm going to use the max function, and in this case, I'm going to say float 3m, and we have something like that. And in this case, obviously, we need to also multiply the lines by the color green because that's what we want. And now we have that, which is really cool. All right, so the next thing that we need to do is render the location of the entity in our radar shader effect, right? And to do that, I'm basically going to use the smooth step function. I'm going to create some kind of a donut shape using those functions. And to do that, it's actually quite simple. So let me start out by basically creating a variable, which I'm going to call, blip, just for the heck of it. And this variable is going to be basically, I'm going to scale the space by 30. And you're going to see why in a second. And we just leave it like that. And then I'm going to get the radius, right? I'm going to get the length of the vector blip, right? So I'm going to do a float, and let's call it r blip. I'm going to get the length of this of blip here. All right. Now, with that length, what I'm going to do, I'm going to create the donut shape that I'm talking about. All right. So how's that going to work? If I create a new variable here, and let's call it the circle. Yeah, let's call it circle for now, right? And if I do a smooth step, right, and I go from 0 to 0.2, for example, and then I provide the variable rblip, what I'm going to get is, if I render this, I'm going to get something like this: color float 3 circle, something that you cannot see because it's way too small, but let me make it like that, right? I get kind of a circle shape. But what happens if I add minus a smooth step, and then do something like 3.5 and 0.9, and then I get rblip, right? And what we get is something like this, kind of a donut shape type of thing, right? And obviously we can play around with the size of this guy, on and on. We can start manipulating it, right? So this is good. This is what we want, right? But what we want is also for the shape, for the donut shape to, like to blink, basically, right? So what I can do, I can use the modulus function to make that happen. So if I declare a new variable t in this case, and do mod, and then I use the time, right? Because we want time to be the one that's going to be do the blinking, and just made it equal to 1 here. And for this parameters, I'm going to do t, and then t plus 0.2, t plus 0.3, and then t plus 9, right? That will create all of that. Obviously, I can also make this a lot slower, because we don't want it to be that big. And finally, we want to make this smaller, right? So we want to zoom out. So if I do 30 here, zoom out something like that, right? And that's okay. So now let's combine everything, right? Let's combine the radar, the spinning circle, and then the blip here. And to do that, what I'm going to do is do max circle, and then float 3. And for the circle here, I'm going to multiply that times a red color, because that's what I want it to be. And once I do that, the things that I'm going to get is, I'm sorry, this is supposed to be color. We get something like that, where you can see the entity blinking, basically, right? But obviously we want to subtract like the location. So let's say we can have the location to be -0.50, -0.6, and it's going to be here. And this will represent your location, right? The location of your player, of the entity that you may have. Now, something else that you can do if you don't want to have this to be separate from the blinking of the spinning circle, what you can do instead of t, what you can do is use the same variable from a if you want to. So if we do a here, we get it. So now what you can see now is that at the right time where the spinning wheel goes around the circle, the entity will also blink. And that's how you do this, guys. It's very simple. Obviously, what you need to do is you need to create some rings, and you make use of the fract function, which will basically only render the fractional part of your function, and then you can create a whole spinning. I don't even know the name for that, but you can use that using the modulus. Always keep in mind that this tangent will return the value is going to be between -pi and pi, so you may want to shift that to be between 0 and 1. Once you have that completed, then you can just render the lines. If you don't want the 4 lines, you can make it 3 lines, right? But in this case, now you need to make sure that you also change the angle, the offset angle, so to 120 in this case, right? And once you have that ready, then you can just do the blinking for your entity. And that is it. All right, guys, I hope you like this video. Please let me know in the comments if you want to see more videos like this. I'll be more than happy to share what I know. I'm also learning, by the way, so if I made some mistakes, please feel free to point them out. Again, I'm learning, and If you know more than me, that would be great because I want to get better at this. And not only because I want to get better, but also I am very fascinated with shaders and the effects that you can create with them. All right, guys, thank you so much. Do not forget to subscribe to my channel. Also, subscribe to my Twitch channel. And if you are a new indie game engine developer, please join my Discord server. We have a lot of indie game engine developers where we share the updates of our own game engines, and we also give tips to people who are developing their own game engines. So make sure to join our server. All right, guys, thank you so much, and I'll see you next time.